Our next problem has natural log of 3x minus 2 equals 2.8. So we're going to exponentiate, and since it's a natural logarithm, we're going to be using the base of e. So I'm going to put an e here and an e here. An e and natural log will cancel, giving us 3x minus 2. And then on my calculator, if I type in e to the 2.8 power, I get 16.444. So now we're going to add the 2 and get 18.444, and then of course divide by 3. And we get 6.148. Okay. Number 9, since it's a base 4 logarithm, we're going to exponentiate with a 4. So 4 to the log base 4 is going to cancel, and we end up with 5x minus 6 equals, and then this is 4 to the third power, which is the same thing as 64. So we're going to add the 6 and get 5x equals 70. And then when I divide 70 by 5, I get x equals 14. Okay, the next section, we're going to still exponentiate, but we're going to have to combine some logarithms and do some properties before we can do that. And then we might end up with extraneous solutions, so we have to be a little careful. So here, notice there's 2 logarithms in the problem, and using our property of logarithms, when I add 2 logarithms together, I can bring that into 1 logarithm by multiplying their inside components. So 5x times an x minus 1 is a distribution problem, and that gives us 5x squared minus 5x. So now this is a base 10 logarithm. There's a little 10 down here that they don't write. So when I exponentiate, I can use a 10. 10 to the log base 10 cancels, and you end up with 5x squared minus 5x, and then 10 squared is 100. Now notice we ended up with a quadratic. So first thing I'm going to do is subtract the 100 over, set it equal to 0, and then do you notice that everything here is divisible by a 5? So if I go ahead and divide each side by 5, I end up with x squared minus x minus 20 equals 0. That's a much nicer quadratic to try to solve because I can factor it easily. Multiplies to a negative 20 and adds up to a negative 1 would be a minus 5 and a plus 4. So when I go ahead and solve that, I get x equals 5 and x equals negative 4. Now, one of these answers is going to be extraneous. And what I want you to do is, for now, just go back to the original problem and try, because it's a common logarithm, try typing in the x equals 5, for this case, and here, and see if it comes out to the right answer. X equals 5 does work, so that is a good answer. However, if I was to plug in negative 4, when I try to take the log of a negative 20, or the log of any negative number for that matter, it's going to give me an error on my calculator because the logarithm is not defined in the negative values. So this is an extraneous solution, so cross it off and write ext. That shows me that you got it algebraically, but it doesn't actually work. So your only answer in this question is x equals 5. It could be a case of both problems, or both answers will work for the problem, and there could be a case where neither answer works for the problem, so you do have to check them. So here in number 14, I'm going to bring these logs together by multiplying their inside components. So you have the natural log. When I distribute that, I get x squared plus 3x equals 1. So here we have a natural logarithm, so we're going to exponentiate because it's a base e with an e. And this one doesn't come out so hot. We end up with x squared plus 3x equals e. Now, e is a number, and if you went ahead and typed in e, or e to the first power on your calculator, you'd find out what number it is. It's 2.718 roughly. So we end up with x squared plus 3x, and then I'm going to go ahead and subtract it over and say minus 2.718 equals 0. Now we're going to have to solve this quadratic. I think, well, yeah, I guess we need a quadratic formula. I was going to say we could use our graphing calculator to find the answers, and that would work, but I'm just going to show you that it's also doable through quadratic formula. So, using quadratic formula, we take opposite of our b term, plus or minus square root b squared minus 4 times A times C. Now, yes, it's going to be decimals, and that's okay. All over 2A. So when I try to simplify this on my calculator, I'm going to go ahead and take the square root of all this stuff underneath the radical. So let me do a couple of typing things here. Let's see. Square root it. And we end up with plus and minus 4.458. We're going to divide this by 2. Now, this gives us two answers. It gives us negative 3 plus 4.458 divided by 2. And it gives us negative 3 minus 4.458 divided by 2. Now, if I go back to the original problem, I'm going to have to take the natural log of whatever this value is for x. And remember, the logarithms are not defined in the negative region for x. So, if I look at what's going to happen here, this is going to give me a positive answer, and this is going to be a negative answer. So I'm going to go ahead and not even bother finding this because I know it's going to be negative, which is going to make it extraneous. But I am going to go ahead and type in negative 3 plus 4.458 and then divide it by 2. I'm going to get a gross answer, negative roughly 0.729. Now, when I go to plug this in to check for extraneous solutions, I know it's going to work. Unfortunately, because we rounded quite a bit when we found the E and then when we found the answer, it's not going to match 100%, but it's going to be really, really close. So that is our answer, 0.729. Okay, and then this next question, we're going to bring together two logarithms. Again, we're going to multiply them. So we have 1 log, and then if I was to multiply x minus 6 times 2x minus 11, I would get, let's see, 2x squared minus 11x minus 12 is minus 23x, and then plus 66. So this is a common logarithm, base 10, so we're going to exponentiate with a 10, so they cancel. And we end up with 2x squared minus 23x plus 66 equals 10. Again, it's a quadratic, so we're going to have to subtract the 10 over and get 2x squared minus 23x plus 56 equals 0. Okay, I'm going to try factoring this first just because I don't want to do quadratic formula again. However, quadratic formula would definitely work. I'm thinking multiplies to a positive, adds up to a negative. Both signs have to be negative. And then 56 could be 8 and 7. So let's try 7, 8. Well, let's find some other options too, just in case. 14 and 4. This might take me a minute. Let's try 8 and 7. And if I check that, that gives me a minus 16 and a minus 7 in the middle, which gives me my negative 23. Okay, good. So when I go ahead and solve these, I get x equals 7 halves, or 3.5, and x equals 8. Now think about, this is really a 3.5, taking these and plugging them into the original problem, the logarithm. Remember, we can only take logs of positive numbers. So if I plugged it in right here, for instance, x minus 6, if I were to plug in the 3.5 minus 6 would result in a negative value, and we're not allowed to take logarithms of negative, so that is an extraneous solution. And if I think about using the 8, this would be 8 minus 6, which is 2, and then this would be 16 minus 11, which is 5, so those would work. So x equals 8 is a good answer. I'm just going to give you a heads up on your homework. Sometimes, instead of adding the two logarithms together, they have a subtraction problem. For instance, something like this. Like this. So when you bring two logs together that are being subtracted, remember that becomes a division problem. And if you ever run into this, it's not bad. You're going to end up with basically a proportion. So, and I'm totally making this problem up. I would have exponentiated with a 10 and said 3x over x minus 4 equals 100. And then if you treat it like a proportion, you're going to be able to solve it. Okay, so that is lesson 8.6, and that is the end of this chapter.